Okay, everyone. I'm just going to give it a minute or two, just because it's kind of like a little awkward, like logging into Zoom meetings for the first time for some people. I am going to record this, so we'll kind of be aware of that. Stuff in the chat and things will get recorded. So don't kind of turn your camera on while you're sitting there in your pajamas if you don't want that to be recorded. I'm going to kind of keep everyone muted, just so that we kind of can keep it simple, and then any discussion you want we can just do in the chat. So if you've got a question, you can do the raise your hand thing, or you can just kind of like send a message into the chat, and as soon as I notice it, I'll try and answer it. Okay, you might hear a few weird noises in the background. That's like either my dog squawking or my guinea pig weaking is the noise that guinea pigs make, or just kind of, you might hear normal noises. We're just kind of trying to cope with the situation at the moment, so just ignore that. But yeah, just let me know if things aren't going well, and I'll do my best. So the plan for today was I'm going to be spending most of the time on the document camera, and then a little bit of time, just kind of talking to you. But I think what we'll be working through mostly is to work on the review for the final document. So if you want to, you can go into Canvas, and that document is available there. I can't quite recall how it's phrased, but if you go into the modules, right at the very bottom of the section that is labeled worksheets, you'll see it says practice for final, and that's the document that we're going to be going through for most of the time today. So I'll just be kind of like, giving my explanation of the answers to that. So hopefully that's helpful. And then I have another bunch of problems that I've printed out as well. And if we get time and people aren't going crazy, we'll go through that as well. So I've printed this document out fairly large and in a bold font, and I'm going to be working with a pretty dark pen. I'm going to work with a Sharpie, I think, most of the time. So hopefully you'll be able to see it on the camera, and it'll be okay. It gets a little weird at times, just kind of moving things around, but it should be okay. We've been doing this for a little while now. So let's get going. So this is just working through that practice for the final. So the first question says, suppose you were handed 2 drinking glasses, each containing a clear, colorless liquid. 4 alternative hypotheses were postulated concerning the liquid in the glasses. Both glasses contain water only. One glass contains sugar dissolved in water, and the other glass contains only water. One glass contains salt dissolved in water, and the other glass sugar dissolved in water. Both of the glasses contained salt dissolved in water is hypothesis 4. So then you've got to be a little bit careful in what they're asking. It says, which of these hypotheses could be rejected? So basically, what ones can you get rid of when you taste the liquid in one of the glasses and determines it tastes sweet? So really, you want to think about what you know. What you know is that one has sugar and the other is completely unknown. That's what you know, right? Okay, so you don't know whether it's got salt, sugar, or just plain old water in it. Okay. So let's see what we've got. So it says, which can 3 and 4 be rejected? One glass contains salt dissolved in water, and the other glass contains sugar dissolved in water. We can't get rid of hypothesis 3. That is a possibility. Okay, so I'm gonna say that A is not really a goer, but let's just check 4. It says both of these glasses contain salt dissolved in water. That one we can definitely get rid of. Okay, all right, now let's check hypothesis 1. Both glasses contain water only. We can definitely get rid of hypothesis 1. And then one glass contains sugar dissolved in water and the other glass contains only water. And we can't get rid of that because that's in agreement with that. So 2 and 3 are possible and 1 and 4 are not possible. So it's got to be answer B there. So all I would say about this is that you just want to be like really cautious and systematic. You're going to have a lot of time. This isn't really something that you can Google the answer to easily. You just got to kind of work through with your logic. But it's easier than that one in the book with the balls and all of that kind of stuff. It's not going to be like, you know, a super challenging one of this type. Okay, so it says a measuring cylinder has smallest increment 0.001 milliliters. Which volume reading was made with this cylinder? So the key thing here is that the uncertainty on that anybody recording a measurement on this one is going to go 1 increment smaller than the spacing on the scale. So they're going to go out to the 4th digit after the decimal point. So fairly quickly I can get rid of B. Then I can get rid of a D because I can see that that only goes out to the 3rd place. And then I can get rid of C because that goes out to the 5th place. And then, yep, sure enough, A is left and that goes at the 4th place. So that's kind of, again, just being really kind of logical and very systematic and just making sure I get it right. Because remember, you have 55 questions. So that means every problem is about 1%. All right, I've just got to reorganize my document camera to get the last question on this page. Here we go. It says, in which of the following pairs of numbers does each member of the pair contain the same number of significant figures? So this is all about knowing the sig figs rules, and it's not too difficult. You just have to keep in mind any non-zero number is significant. Any buried or confined zero is significant. Leading zeros are never significant, and trailing zeros are only significant if the number has a decimal point. So in this first case here, the 39 has 2 significant figures, and the 3090 has 1, 2, 3 significant figures. This guy isn't significant to 0 on the end because it's a trailing 0 and there's no decimal point there. So that one, they don't have the same number of significant figures. That would have been 2 and 3. In option B, the first number here, 2 non-zeros and then 3 trailing zeros that count because there's a decimal point there. So that guy's got 5 significant figures. This one here, it's got 2 non-zeros and 2 buried zeros, so that's 4 significant figures. So we've got 5 and 4, we can get rid of that one. Okay, in C, both of our numbers have both leading and trailing zeros, and they also have a decimal point. So that means that in both cases, all of the trailing zeros count. Leading zeros, however, never count. So our first number there has 4 significant figures, and our second number has 3 significant figures. So it's not C. So odds are it's D. All right, so we've got 1, 2, 3, 4 significant figures because the trailing zero doesn't count, 4. And then this guy, leading zeros never count. And then we've got 4 non-zero numbers, so that has 4 significant figures. So very confident that that guy is the correct answer. So we're doing okay. We've been going for about 8 minutes and we've done 3 questions. You're going to have 120 minutes and you're going to have 55 questions. I'm just doing a little bit of math. That works out to about 2 minutes per question. So you can go really quite slow and be successful. We're doing just great. All right, let me know if there are any questions via the chat. Okay, here we go. So here we go. It says, what is the correct number of significant figures in the answer to the following sum? So the first thing I want to do is get a good answer on the calculator. 8.65 plus 19.6 plus 44.05 plus 88. And I got 160.3. Now I'm going to do it again because, you know, I don't want to make a mistake. Just convince myself that I got the right answer because it's real easy to put it in, and I do. So now this is only an addition, so I know it's all about the plus or minus. And so I'm looking here for what number has the smallest plus or minus. And it's going to be this one because it only goes out to the ones. And all of the others go, this one goes to the second decimal place, this one goes to the first, this one goes to the third. So my answer needs to be cut off at the ones. So how I'm going to do this is I'm going to make this look like that. Just put the 0 at the end, which would give me 3 significant figures. So it's not 2, it's not 4, it's not 5, it's 3. I'm just answering May's question now. Hi May, it is indeed, it is. I made some slight edits towards the end of this document compared to what's on Canvas, but that's just eliminating some questions that are not relevant yet. But May asked, is this the practice test on Canvas? It is. So if you go to the bottom of the section called worksheets, it's right there. Yeah. Okay, so the next one, they give you the calculator answer and then they're asking you to round it off. So it's a multiplication problem, which means it's all about the sig figs. And so I've got to look at my two numbers and see how many significant figures are in each. So that guy's got 4, and because there's no trailing zeros, no leading zeros, and only non-zeros and buried zeros. And then this guy's got 1, 2, 3, 4, 5. So my answer has to be cut off at 4 significant figures. So 41.3, and then I've got to decide, do I keep it at 8 or do I round it up to 9? Now, because it's 8 that follows, that's going to become 9. So it's going to be 41.39. There we go. Okay, all of the others have too many sig figs. Now, I didn't need to worry about doing the rounding because this is the only one that had 4 significant figures. So even if I hadn't done the rounding, I could have eliminated all of the other ones. All right. So this one says, do the following calculation and decide how many significant figures the answer should have. You don't want to jump to any conclusions here because whenever you're kind of going up, when you add these two numbers together, you're going to get a number greater than 10. And so it's going to be non-obvious what the answer to this will be. So first of all, I'm going to get a calculator answer, 5.02 plus 6.119 plus 0.04117. And I got 11.18017, and I'll just double check that. 5.02 plus 6.119 plus 0.04117. Yep, looks great. And then now I've got to decide about significant figures. And again, because it's an addition, it's all going to be about the plus or minus. So this guy goes out to plus or minus 0.01. This one goes out to plus or minus 0.001. And then this one goes all the way out to 0.00001. So it's this number here that is going to determine the significant figures. I've got to round it off at the second digit after the decimal point. And so that's going to leave me with 1, 2, 3, 4 significant figures. Okay, so I think that's, that's kind of not too bad. All right, now the next one's kind of tricky. It says a rubber band is measured to have a mass of 0.978 grams. What is the total mass of 15 of these rubber bands expressed to the correct number of significant figures? And this is a little kind of like just a little kind of point that was mentioned along the way. And it said that when you have a whole number of objects, we're going to treat a multiplication of a number of a measurement by a whole number as though it was an addition. So how we're going to treat this problem is as though we were adding 0.978 to itself 15 times, rather than treating it as 15 times 0.978. So that doesn't mean that we're not going to do this for the math, but we're going to treat the significant figures as though it was an addition problem and it was all about the plus or minus. So 0.978 times 15 gives me 14.67. Now the significant figures here are based on where the greatest uncertainty is in what I'm adding together. So I'm actually going to put a 0 on the end there to get it out to the 0.001 place. So that's a little bit kind of confusing, right? So whenever I'm multiplying a measurement by a whole number multiplier that's an exact number, I'm going to treat it as an addition rather than treating it as a multiplication problem. And the reason is, if I treated it as a multiplication, I would have cut it off at 3 significant figures and I would have lost some of my my digits there. So the answer to this guy is 14.670. So that's kind of probably one of the harder ones to do with respect to significant figures. So I can, do something similar if you don't understand that well. All right. Number 8, we're almost a fifth of the way through here. So when you do your online multiple choice test for the final, you'll have a little timer. So you want to keep an eye on that, because remember, you won't be able to go forwards and backwards. You want to answer every question kind of very slowly and systematically, but of course you don't want to burn through all of your time. So, I'm kind of keeping an eye on this as I go now, and it's 2:34 and we started near 2:20, so I'm feeling okay. I'm not obsessing over the time, but I'm kind of keeping an eye on it. All right, now this problem is they're describing math in words, so we have to get sort of like our head straight what they're asking. So they're asking us to subtract 1.2 from 123.96. So this is a subtraction, so it's going to be all about the plus or minus, right? So I'm going to get my calculator answer, and then I'm going to cut it off to the correct significant figures appropriately. So 123.96 minus 1.2, and I got 122.76. Okay, so now I've got to think about significant figures. This guy goes out to 0.01. This guy goes out to 0.1, so I need to cut it off at the 0.1s. And that'll give me 1, 2, 3, 4 significant figures. Now you can see here, if I used my multiplication significant figures rules and I went with the smallest sig figs, I would have got this totally wrong, because that guy's got 2 sig figs and that one's got 5, and I would have picked 2 sig figs, which is not the correct answer. So whenever you're doing multiplication and subtraction, make sure you're using the correct rule, or otherwise you're going to most likely get the answer wrong. You may get it correct. Okay, so here it says, assuming all numbers are measured, that means there's no exact numbers. The answer to the following calculation expressed to the correct number of significant figures is. And the important thing here is that when you've got a fraction, you want to just put each part of the fraction, top and bottom, the numerator and the denominator, into parentheses. Now, in this case, you don't strictly need to put the the top line into parentheses, but it's just a good habit to get into, to put everything into parentheses. So I'm going to get a correct calculator answer. And then we will take it from there. So my calculator answer ends up being like 1422, and I'm just going to put a bunch of digits here, 2619, and it keeps on going. Okay. Now, how do I think about my sig figs? Well, I'm doing multiplication and division. So it's about the sig figs and not the plus or minus. So we've got 3 sig figs there, 4 there, 3 there, 4 there. So it has to be 3 sig figs. So that means I'm going to cut it off exactly there. So it's going to be 1, 4, 2. And then where I'm cutting it off there is going to become a 0. Okay. So that's what I'm doing, right? And I don't round this up to a 3. So I'll just leave that as a 2 because this is under 5. So it's 1420. Now, some people make the mistake of reporting it as 142 or something else, but it's not. It's 1420. You'll also see here that they've put the answer in that you get if you forget to do your parentheses. So if you just enter that problem without the parentheses into most calculators, not all of them, you would have ended up with answering it with 1140 instead. So that would be the wrong answer. If you didn't use the parentheses, you would have got B. Okay, cool. All right, so there's that. Okay, number 10, we're about a fifth of the way through. Again, it says, assuming all numbers are measured, the answer to the following calculation expressed to the correct number of significant figures is. Now, the difficulty about this one is that you can see that you've got subtraction and multiplication in the same problem. So what that means is you got to do both rules, the plus or minus for the subtraction, and then you've got to consider the sig figs for the multiplication. So we just kind of follow the standard order of operations. We're going to do what is in parentheses first and get an answer for that. So let's do that. And we won't round that answer off. We'll just write exactly as it appears from the calculator. So doing that, I got 88.389. And then I'm going to make a note where I would have rounded that off if it was the only thing I was doing. So this is going to be about the plus or minus for the subtraction. So this guy goes out to 0.001 and this guy goes out to 0.01. So I would have rounded that off at the 8 there if that was the only thing I was doing. So I'll keep an eye on that. So if that was the only operation I was doing, this would have 4 sig figs. Okay. Now I'm going to do my multiplication. Okay. So I just keeping my calculator answer in there, not rounding anything, times 18.057. I'm going to get my calculator answer. It ends up being 1596. I'm off the page. Let me move that up. 1596.040173. And then I've got to think about my sig figs. This number has 4 sig figs. I'm doing multiplication. So I need to know the number of sig figs over here. That's 5 sig figs. And so that's telling me that I got to cut this guy off at 4 sig figs right in there. So it looks like the only one that makes any sense at all is that one. Now, you need to be, hang on, sorry, I'm looking at Ron's text here. Ron just asked me a question, so I'm just kind of seeing if I can answer it. Ron asked, in question 9, if the product was 1428.26, but using the 3 sig figs, it would be 1430. But If it was sorry, Ron, I'm trying to answer your question. Yes, but that's not what we got for the math there, I don't believe. So, sorry, I'm talking to Ron here, trying to answer his question. Ron asked a question about question 9 in private chat, and I'm trying to resolve it for him. So just give me a moment. So give me a second. Probably hear me typing away. All right, okay, so moving right along. Sorry about that. I just wanted to make sure I answered the student's question. All right, okay. All right, so we're getting there. We've done about 1/5 of this practice test. Okay. All right, so here we go. When the number 6002.0 is written in proper scientific notation, it is. So I guess the thing that's important here is to recognize that we're going to need a positive exponent, and we can't change the number of significant figures. So when I look at this number at the top here, I see that it's got 1, 2, 3, 4, 5 significant figures. So if anything doesn't have 5 significant figures, I can get rid of it. So that helps a lot. So B can go because it only has 2 sig figs. C can go because it only has 4 significant figures. So then my choice becomes, is it D, which is kind of run over the page because I enlarged the font, or is it A? And there's a couple of ways of doing it. I could write A out just by moving the decimal point 4 spaces to the right, and you would see if I do that, I end up with a number that is 10 times too big. So it is not A. Now D, it's times 10 to the 3. So if I move the decimal point 3 spaces to the right, I end up with exactly what I want. So that means that it has to be D here, okay? All right, so that's not too bad. It's just kind of being slow and steady and using some logic there, and you'll get there. All right. Okay, this is kind of early stuff, sort of chapter 4 stuff, I think it is. And it says when a pure substance is analyzed. Now, the thing about when it says that it's a pure substance is that immediately means that it's not a mixture. So it's either a compound or an element. It can't be a mixture. So it says it is found to contain carbon and chlorine. So that immediately tells you that this stuff is a compound. So then it says this substance must be classified as an element. We can get rid of that. A mixture, we know it's definitely not a mixture. Or then C, a compound, which is the correct answer. Now, option D was both B and C. And it can't be both an element and a compound. That's never going to be correct because compounds always contain 2 elements or 2 atom types, and elements only ever contain 1 atom type. All right, so now we have a question concerning physical and chemical changes, and I'm not trying to trick you in any of these questions on the finals. I've always put the keyword in italics here, and you can see that I did that up here. I put pure substance in italics to try and help you recognize what was going on, and here I put the word chemical in italics, and that's pretty typical. So it says, which of the following is an example of a chemical change? It says burning candles, slicing cheese, dissolving sugar in water, or freezing water? Well, phase changes are not chemical changes because they don't result in a new substance being formed. And subdividing or cutting something up is also not a chemical change because it doesn't result in a new substance being formed. When you dissolve one substance in another, when you make a solution, you could actually separate those two components from one another again later, and by removing the solvent, you're not actually changing the chemical composition or the arrangement of atoms in any of the substances there when you do that. So C, dissolving sugar in water, is not a chemical change, but combustion or burning is a chemical change. Burning something is reacting it with oxygen. Okay. So the next question, again, they put a word in italics there to try and help you out. It says, is not. So which of the following is not a mixture? So air is a mixture of many gases, carbon dioxide, oxygen, nitrogen. So it is not air. I need a little bit of general knowledge in order to answer that one. And it says salt water. And salt water is a mixture of sodium chloride or salt and water, along with a whole bunch of other things, including like fish and whales and jellyfish and stuff. So, you know, it's not going to be that guy. I guess that would be more strictly true for seawater. Now, milk has got a whole bunch of stuff in it. It's got all sorts of compounds in there. It's got like vitamin D and fats and water and lactose and all of those things that are in milk. So we're going to get rid of milk. And then that just leads to the last one, carbon dioxide. And carbon dioxide is the compound CO2, and compounds are pure substances, not mixtures. So another way of phrasing that question is, which of the following is a pure substance? Right? That would be another way of phrasing that question. All right, so here we go. Number 15, which of the following describes a physical change? A piece of paper is burned. Now, combustion is a reaction with oxygen. It's a chemical reaction, so it's not a physical change. A nail rusts. Rusting is, again, it's a reaction with oxygen to form an oxide. It's a chemical change, not a physical change. When something explodes, it's decomposing, it's falling apart into multiple fragments. That is a chemical change, not a physical change. And then ice melting, phase changes are always physical changes. So this guy's gotta be D. All right, so we're getting there. We're almost through another page. The next question says the number of significant figures in, and then it gives a big number there with a lot of leading zeros. So the first thing to keep in mind is that leading zeros never count. So we just want to eliminate those guys immediately. So we're only left with 5 numbers after that. So we can get rid of 7. It's not 7 because it is at most 5. And so then our number does have a decimal point. So all of the trailing zeros count from here on in, and then buried zeros always count. So that means we've got 1, 2, 3, 4, 5. So I think the big thing there is you don't want to make an error with like just counting. You know, you don't want to kind of like skip a number as you're counting, which is really the reason that most people would get that wrong. Okay, so just be very, very cautious with that. All right. Slowly getting there. Now, this is a question that you've had before that was kind of worded slightly differently. It says the rule for recording significant figures requires that the experimenter records as many digits as he or she wants, that's not a requirement. You could do that if you wanted to, you'd be wrong. Only measured digits. Well, that's not correct. What we said way back in the beginning was we always include measured and one estimate. So you only get to estimate one digit. So it's not only measured, because you get all of the measured ones and an extra one. This is only non-zero digits. That's not correct, because buried zeros are very important. And then finally, here we go. This is the correct answer. All measured digits plus one estimated digit. That's exactly the definition that we're going to use all the way through. Okay. All right. Now, it says this is talking about the definition of a chemical change. So chemical change, what happens is the way that the atoms are connected to one another is reorganized, and as a result, we get new substances forming. So when a substance undergoes a chemical change, it is always true that it condenses. That's not true. Some doesn't always form a liquid from a gas. It changes state. That's also not true. There are plenty of reactions that only involve one physical state. New substances are formed. That is true. And then heat is absorbed. That's not actually true. Some reactions do absorb heat and they will make you cold, but others release heat and they will make you hot. So it's got to be C. All right, 20. I feel like we're doing really well here. Which of the following statements does not describe a physical property? So does not, we want to be aware of that, a physical property. So we're looking for a chemical property. So sparks are created when sodium is added to water. That looks like it's being a chemical reaction between the sodium and the water. So I'm going to say that yes, indeed. A strip of magnesium weighs 7.49 grams. That is definitely a physical property because you can measure that without attempting to change the substance. Snow forms in clouds on cold days. This is gaseous water becoming solid snow. That's a phase change, and that is definitely a physical change or a physical property. And then it says mercury is a liquid at room temperature. And again, that's a physical property because you can observe it without attempting to change the composition of the mercury. So it's got to be A there. All right, cool. So then we have to be a little bit careful with this next one as well. It says, which of the following is a property of both solids and liquids? So solids have the property of fixed volume and also fixed shape. Liquids have the property of fixed volume, but they have a variable shape. So the thing that these two guys are going to have in common is that they both have a definite volume. So we can get rid of A, definite shape. We can get rid of B, indefinite shape, because solids have a fixed shape. And then we know that it's C, but we're still going to check the last one. It says indefinite volume, and that's not correct for either of them. So there we go, C. All right, so that seems like we're doing okay. I'm going to stop at around about problem 25, and we'll take a little break because it's kind of boring as much as anything that I just can't hear you guys, and I'm just kind of feel a little crazy talking to myself. So let's see. Let's get through these next 5, and then we'll take a break for 15 minutes or so. All right, so it says, how many grams of sugar are contained in a 15.3 grams of a mixture of sugar and water that is 26% sugar by mass? So we're using a percentage as a conversion factor here. So what we're starting with is 15.3 grams of mix, and where we want to end up is grams of sugar. So what I know is that it's going to be, because it's only 26% sugar, it's going to be a number that is smaller than 15.3. So I can get rid of D to begin with. So how I do this, the best way of doing these problems is by using the percentage as a conversion factor. So I need grams of mix on the bottom and grams of sugar on the top. And how I interpret that percentage is that I get 26.0 grams of sugar for every 100 grams of the mix. So that ends up being 15.3 times 26 on 100, and I got 3.978. 3.978. And so this needs to be, well, that would be 3 sig figs, that's 3 sig figs. So this is going to be 3.98 to the correct number of sig figs. So it's got to be A. There we go. All right, so that's not too bad. Now, if I make a mistake, because I didn't actually practice this beforehand, I have to confess, please let me know if I've made an error, but I'm feeling reasonably confident so far. Okay, now this one is a similar sort of idea, but instead of using the percentage as the conversion factor, we're going to be using density as the conversion factor. So it says, what is the mass in grams of 40.7 mils of a liquid if its density is 0.91 grams per mil? So I'm starting with 40.7 mils, and I need to end up in grams. So I've got to multiply it by the conversion factor that has mils on the bottom and grams on top. And I don't really need to do anything. I can just use the density directly. 0.91 grams per 1 mil, and then just cross that off. So it's going to be a number that's a little smaller than 40.7. So 40.7 times 0.91, and the calculator answer there is 37. Okay, so 2 significant figures for this guy. So 2 significant figures over here. Not that, not that, not that. It's A again. Okay, there we are. All right. Now, this is simply using the density formula. So density equals mass on volume. And if you had forgotten that, you could kind of just look at the units for the densities that are given. So I can kind of see immediately that these units are messed up. So density has units of mass over volume. So it's not going to be C because the units are all messed up. So let's just go ahead and calculate that. 67.5 on 32. It's going to be 2 significant figures. So 67.5 divided by 32, 2.1 grams per centimeter cubed. So it's going to be B in, oh, we've got 2 B's in this case. That won't be happening in the final. I have no idea why we have 2 B's. All right, we're getting there. We're getting very, very close. So it says the accepted value of the boiling point of acetone is 56 degrees Celsius. What is the percent error for a reported value of 57.2? So what I know is that it's a tiny little bit over, right? It's a tiny little bit over. So I'm pretty confident that I'm going to be able to, that it's not going to be any of those two. And my formula for percent error is the measured minus what we call the accepted over the accepted and times 100. Okay, and so I've just got to put my numbers in and make that happen. So as long as I don't confuse anything, what I measured was 57.2. The accepted value is 56. And I got to divide that by 56 and times it by 100. So 57.2 minus 56 divided 56 times 100, and the error ends up being 2.1. So it equals 2.1. Okay, so it's that guy. All right, now just be aware that the other options are most likely common calculator errors. So you want to be kind of very, very careful with entering things into your calculator. And the key thing here is when you've got a fraction and you've got multiple parts to either the numerator or the denominator, is to make sure you've got your parentheses there, or otherwise you're at risk of getting the wrong answer. Okay, so I hope that was helpful. And what I'm going to do now is we'll take a break, because we're about our sort of, normal time for taking a break. We'll take a break for about 15 minutes. We'll come back at about 3:20, and then I'll go through the remainder of this practice exam that I posted, and you can hear my reasoning from my answers. And then also if you have anything else that you would like to go through, just kind of send me a chat, and I'll try and respond accordingly. Okay, guys, so I'll see you at 3:20.